Well, we'll list all of our methods of factoring. So your traditional methods that you've been working on for a couple years have been taking out a GCF, guessing and checking, or splitting the middle term with we've done grouping, and you've done like your special patterns like the difference of perfect squares, difference of perfect cubes, difference of squares, difference of cubes, and the sum of cubes. Those are all what I would consider to be your traditional methods of factoring, and I only call them traditional because you work on them most often. When those aren't possible, the final method of factoring that you need to know how to do is understanding that long division is your way of factoring out something. So on your warm-up, we factored out x minus 3. So what we got was, when we divided out x minus 3, this was our answer. Your original factored into this times the x minus 3 that you divided out. So those were like the two factors of your original. Now, x minus 3 actually is not a nice factor of your original polynomial because we had a remainder, right? Nice factors go in evenly and you would have no remainder. Okay? So the only thing with long division factoring is that you don't just know what to divide by. You have to be told somehow. So in this particular problem, they want us to find the zeros. And if you look at this original function, it actually is going to be factorable by one of our traditional methods, but they specify to use long division. Most of the time they won't make it something that's possible to do. This one would be groupable, but we're going to do it by the long division method and just kind of show that they're the same. So doing long division, we're pulling out an x plus 1. Alexa, what goes up here first? No. X times what gives me x cubed? Good. And then what do I write down here, Angie? Well, just let's fill in here first, and then we'll do the subtraction. So what term am I going to put here? Nope. X squared, nope. I'm multiplying this by this. X cubed, and what goes here? Y minus. X squared times a positive 1 is a positive x squared. Right? Then we subtract in between each term. So x cubed minus x cubed will be gone. Negative 2x squared minus another x squared is negative a 3x squared. Bring down your next term. Morgan, what goes up here next? Very good. Sierra with an S, what lines up underneath here? Good. Do my subtraction. What do I get, Owen? Try again. Positive 2x. Bring down your plus 2. And then it goes in 2 times. 2x plus 2. Subtraction. Remainder of 0. So it went in perfectly. So what we just did was took that original and we factored out an x plus 1. And we were left with an x squared minus 3x plus a 2. And then we can continue factoring the rest of it by our traditional method. So the x plus 1 is done and finalized. But the trinomial we can guess and check on, or we can split the middle term. I'm going to guess and check because it's a pretty straightforward x and x situation. That's the only way to make x squared. And there's only a couple ways to make positive 2, while also on the outer and the inner getting negative 3. So that's going to be a negative 2 times a negative 1. And we're trying to actually find the zeros. So when you tee this up, you get x equals negative 1, positive 2, and a positive 1. So you have 3 zeros. You obviously have to always show your work algebraically, but you definitely can use your calculator to check. So if I wanted to check what the zeros were visually of this function to see if my algebraic work was accurate, I would just type in the function, graph it, and see where it crosses the x-axis. Here are my zeros: negative 1, positive 2, and they're all covered. So use your calculator and the visual knowledge that you have and pair it with your algebraic stuff and make sure it all adds up. Are there any questions on that? Okay, so that one asked us to find the zeros of the function. This one is asking us to solve this function. Pretty much the same thing. The zeros are the solutions. Okay, so this particular one, if you try to just jump right into solving by factoring, like we've done in the past, you wouldn't be able to do it by your traditional ways of factoring. This one is not groupable. But they are going to tell you that 2 is a 0. So if 2 is a 0, then what factor, Eric, can I divide out? What's the factor that would go along with a 2 being a root? Like if we go back to even this. If you knew you had a root at 2, what's the factor going to be? Who can help them out? Sierra? X minus 2. So whatever if your 0 is 2, then when you kind of go backwards from teeing it up, your factor is x minus 2. So given that that's a 0, we know that that should divide out evenly. And we'll use that as our kickstarter for this factoring process. So we'll long divide out x minus 2. Everyone go ahead and do that on your own. What do you have so far? What goes up top? 2x what? No. X times what gives you 2x cubed? Yes. And then multiply that 2x squared times the x minus 2, and what does it give you right here? Why negative? 2x squared times x. Why are you telling me negative? Yeah, and 2x squared times negative 2 is 2x squared times negative 2. Nope. 2 times negative 2 is negative 4x squared. Subtraction, negative 5 plus 4 is negative 1x squared. So, if you knew something was a 0, that tells you that when you get a remainder of 0, that's a good thing. That should happen. If you know it's a root, if you know it's a 0, then it should divide in evenly. If it doesn't, that should be a red flag. Stop and go back. So now so far we've taken this and we've factored it into x minus 2 times 2x squared minus x minus 1. And now that we're down to a quadratic, if quadratics are factorable at all, they will be able to be done by hand. So again, I'm going to go with a guess and check on it because there's not too many options. The only one for the first two terms is 2x and x. The only numbers that multiply to get 1 are 1 and 1. But because it's a negative 1, one of those has to be positive, one of those has to be negative. And in figuring that out, you want to make sure your outer and your inner products make negative x. So we want the 2x to be negative, so negative 2x plus 1x would make the negative x in the middle. So when you tee each of these up, you get 3 solutions. X equals, what's your first one, Elena? 2. Haley, your second one? Good? Because you'd have to, that one, some people might want to write that out. You have to subtract the 1 over and then divide by 2. And your third one, Lucas, B? Well, I'm taking my factor and I'm just giving a numerical root. 1. Very good. Okay, so we've solved the equation by factoring, yes, but your factoring involved long division. Okay? The next one is very similar seeming. Again, they're asking you to solve. Again, they're telling you a root to start with. The tricky part is if x equals negative 3/2 is the root, what's the factor? We did this before break a little bit. We got to refresh it because the previous one that I asked Eric about was a whole number. Those are fairly simple because you just switch the sign, right? If your root is at 2, then your factor is x minus 2. This is a little bit different because we don't want to just write x plus 3/2. That long division would not be pretty with a fraction. 2x plus 3. Now, how did you do that? Right, so if you're kind of unraveling that root, you'd multiply both sides by 2. You'd have 2x equals negative 3. And then to get it back equal to 0, you'd add your 3 over. So prior to teeing it up, the factor must have been 2x plus 3. So that's what we would long divide out. Now, I'm just going to fly through this, so if you can go through it fast. If not, don't worry about all the work. Just worry about your answer. Oops. Okay, so I have factored it, again, if you don't want to worry about copying down all that work, that's fine. I have factored it into 2x plus 3 and 6x squared minus x minus 1. Again, with the quadratic, to factor it further, you can guess and check or split the middle term. There's a couple options on my 6. 1 and 6 or 2 and 3, but luckily on my last term it has to be 1 and 1. So not really too difficult of a guess and check, although if you're more comfortable splitting the middle term, remember that you're looking for 2 numbers that multiply to get negative 6 and add to get negative 1. What are they? What multiplies to get negative 6 and adds to get negative 1? Chris? Right, so if I wanted to split the middle term, I would do 6x squared minus 3x plus 2x minus 1. I'd go through my grouping, pull out a 3x, pull out a 1, and my terms are 2x minus 1 and 3x plus 1, because that was a positive one I pulled out. Guess and check, probably would have gotten that for a lot of you anyway. But now to solve, I actually need to give solutions. So x equals negative 3/2 from the first factor. That's the one they told me anyway. They told me that was a root, so obviously that's a solution. 1/2 and negative 1/3. So I'm going to have to subtract over 1 and divide by 3. Any questions? So using, we've already solved polynomial functions. We found polynomial roots. We did that way back when we did factoring by our traditional methods. So we're redoing something we've already done using a new technique because the old stuff isn't always possible. Okay? On some exercises, they're not going to tell you the root to start with. They might show you a picture, or you might have to type it into your calculator yourself and figure it out because they'll want you to show your work algebraically. So in order to show your work algebraically, you have to do long division. In order to do long division, you have to know what to divide out. In the last two examples, they told us verbally, here's your root. This type, they're showing you visually what your root is. So use a graph to determine a solution. Then use the information to solve the rest of the equation and find the other solutions. So just based on, again, make sure you remember what the scale means. Your x-axis is going from 0 to 4, counting by ones. So this is 1, this is 2, this is 3, and this is 4. So if the root is 2, Mike, what's the factor? X minus 2, so that's what we will long divide out. And then once we do that, we'll have a quadratic, and we'll have to factor the quadratic the rest of the way. Does that make sense? I'm going to skip that. Yeah. Which one you start with? No. What it will change is if you were to take out a different factor, your quadratic will look different. But once everyone's done, your 3 factors or your 4 factors should all be the same. So did everyone understand her question? If you do look on your calculator and you see 3 different root options, does it matter which one you start with? And the answer is definitely not. It does not matter. Everyone's will transpire differently, but you'll all end up at the same spot. Okay? This one gives you your function, but gives you a table to choose your root. Now, roots are x-intercepts. Solutions are x-intercepts. And based on your flashcards, x-intercepts are when what? Y equals 0. So if you're going to find your root, look where your y equals 0, which is here. Sorry, I didn't copy great. And so what is the root? 1, right? And if 1 is your root, what's your factor? X minus 1. So that's how we would start dividing things out here. And again, you'd divide out that root. You'd be left with a quadratic answer. You'd factor your quadratic the rest of the way, tee it all up, give your solutions. And last but not least, they don't give you a picture. They don't give you a chart. So they just want you to use your graphing calculator to find a starting point. So you would type in x to the third minus 4x squared minus 7x plus 10. And here's where Haley's question would come back into play. Does it matter which one I start with? Definitely not. It looks like -2, 1, and 1, 2, 3, 4, 5. But you may just want to check just in case they're not as exact as you think they are, and do your second trace and look for your zeros. And let's say I start with, I'm going to start with this one. Left bound, right bound, And then it is exactly at -2. But be careful, because if it's at like -2.2 or something, you might not, your naked eye might not be able to tell that. You'd want to trace it to be sure. So if I'm going to start with a 0 at x minus, or at -2, then my factor is x plus 2. I would go through, do my long division. I expect a remainder of 0. This is going to then factor into x plus 2 times whatever the quadratic is. The quadratic is then going to be taken out the next step. And then you're going to tee up all 3 factors, and there are your solutions. Same thing over and over and over again. It's just how you're given your starting factor that you have to really pick up on. Okie doke. Okay, so I started a few minutes early because I want to give you back your quizzes from